In this video, we will start shear force and bending moment. So first we will understand the sign convention. So for shear force, if this is a beam, then if we measure point from point A side to the left, then at this surface, if the force is upwards, then this shear force will be positive, and if it is downward, if we measure from the side of point A on this plane, then the downward shear force will be negative. Similarly, on opposite side, if we measure from point A side towards the right, then on this surface shear force will be downward, then it is positive. And if we measure from point A and if the force is upward on this plane, then it is negative. We do not have to remember directly, but when we solve numericals, it will automatically we can identify the shear force is positive or negative. And if we take opposite sign convention, then also the result will be same, just the sign will be opposite, but we'll still get the maximum shear force location and bending moment at exact same location. Now for bending moment, if the beam is having the shape like this, it is called as sagging, and which is considered as positive. And hogging means the shape is like this and bending moment is in this direction, then it is negative. So as per the shape of the beam after deforming, we'll get the sign positive and negative. Sometimes this is the direct question asked in some of the examination for 1 mark, so we have to remember sagging and hogging position like this, positive and negative. Now I'll see some basic beams which we'll be using for our analysis. So types of beams, first is simply supported. We know that there are two supports, so there will be two reaction and force will be anywhere, and this is a point load. So this is and load can be of different types on this beam, but there is a two supports at the end location, so it is simply supported beam. Overhanging beam will also have two supports, but there will be some overhanging part outside the beam which is unsupported, either on one side or both side. There will be some loads which will be acting. There can be point load or uniform or varying load, but I have shown it as a point load here for example only. So two supports, and there is a overhanging on one side or both. Continuous beam, where there are multiple supports, there can be 3 4 or multiple supports are there, and loads can be any type of load, but it is continuous if there are more supports continuously. The fixed beam, if we see, then in fixed beam both the ends will be fixed, and we have to analyze it like there will be reaction forces and moment. There can be horizontal force as well. So this is a fixed beam where both the ends are fixed, they are welded or jointed rigidly. In cantilever beam, it is one end is fixed, other end is open, and load can be of any type: point load, uniform, distributed, varying load. So this is a cantilever beam, and this particular four examples are of propped cantilever or propped beams. So here what happens is we have a cantilever beam and additional one support at the end. So there will be one support, roller support or fixed support, any type of support can be there. So one end is fixed, the other end is supported. So this is a propped cantilever beam. There can be different types of load variation also. These both are same, but just the load variation is different. Here here if we see, there is a spring used, so spring can be deflected, and there can be spring force acting on the beam reaction at the end. Instead of support, there is a flexible spring. So this is also probed. And there can be two beams, cantilever beams, fixed by one support, which is a circular or a cylindrical type of support, which is giving reaction and transferring load from upper beam to lower beam. So, and there can be different load variation also. This is just for example. So this all are propped up beams which are statically indeterminate. We have to determine it by having this condition at this location. We have to evaluate the reaction force with the deformation of the beam. So we'll see some analysis of some beams in future videos. So this is just an introduction of different types of beams which we are going to analyze. So see you in the next video, and thank you for watching this video.